So there is one example of that to calculate the length of the vertical curve. Let us find the length of the vertical curve connecting two grades. 0.5% means that there's a rise, and negative 0.4% means there's a fall, where the rate of change of grade is 0.1% per 30 meters, right? So the length of the vertical curve is g1 minus g2 over r. No, g1 in this case is plus zero point 0.5 and g2 is minus zero point 0.4. So putting those values over there, the length of the vertical curve comes out to be 270 meters. And then there are different types of the vertical curves. First one is the summit curve. अब summit curve क्या है कि when an upward gradient is followed by a downward gradient, then you can see that there is a summit curve like this one. You can see this is an upward gradient, this is followed by a downward gradient. No, this is the summit curve. Now there is a second one case as well, when a downward gradient is followed by another downward gradient. Okay, so that is the again an example of the summit curve. Uh, it is over here, as you can see. Further clarification could be that, let's say you are moving down the hill and there is a certain slope, right? And right after this, there is another downward slope over here. Now, in this case, the curve that will join these two, that will be called a summit curve. So, when a downward gradient follows another downward gradient, there is an again an example of the summit curve. Sag curve is formed when a downward gradient is followed by an upward gradient, like this, as you can see over here. This is downward gradient, and this is followed by an upward gradient. Now, this curve is called the sag curve. Or if an upward gradient is followed by another upward gradient, let's say you are moving up the hill and there is a certain slope, and then after this the slope changes, but still it is an upward gradient. Now in this case again, the curve that will be formed, that will be a sag curve. So there are basically two types. Summit curve, that is when an upward gradient is followed by a downward gradient, or a downward gradient is followed by another downward gradient. Then there is sag curve, that is a downward gradient is followed by an upward gradient, or an upward gradient is followed by another upward gradient, right? So these are different types of the curves. Then we have setting out the curve. No, a curve, it can be set out by using two techniques, the tangent correction method, and the second one is the code gradient method. Normally we follow the tangent correction method. No, what is the theory behind it is that what happens over here is that if I can show you that, let's say this is a certain, you can say a certain hill, and you have to provide your vertical curve over here, right? Now this is the profile of your vertical curve. ठीक है जी. Now what happens is there, uh, let's say if this is point P and the corresponding point on the curve is P1, right? And now y is the tangent correction, or the distance that, or the depth that we need to remove from the top in order to have the corresponding point on the curve. So if we can calculate somehow this distance y, right, then at different points along the grade, at this point and at this point, this point, this point, if we can somehow calculate this tangent correction, right, then, and we can subtract it from the corresponding point on the grade, from the reduced level of the corresponding point on the grade, then we can have the corresponding point on the curve. So we will be having these points, and simply we will join them, and we will be having a smooth curve over here. So this is pretty much the concept of the tangent correction method, and the relationship uh, for that tangent correction, that is this one. If I can clear this over here. No, the relationship that we are going to use is this one. Y is equal to g1 minus g2 into x1 square over 400 into L, right? Over g1 and g2 are the two slopes, right? And x is the corresponding distance along the gradient along this length, that right? And this small l is half the length of the curve, right? So this is the technique that's called tangent correction. You can apply that, and you can calculate the corresponding points for any grade on the parabolic curve, right? As you can see over here, x1 and x2, these are the distances along the slope measured from the tangent point, and L is half the length of the vertical curves, and G1 and G2 are the percentages of the grades. Now, there are two that you need to remember while performing the calculations for this vertical curve. The first point is that the length of the vertical curve is assumed to be equal to the length of the two tangents. That is, if you can see this figure, this one, if I can, if you see this figure over here, this length T1B, this one, this is equal to T1B1. Similarly, T2B, this is equal to B1T2. So he is suggesting that the length of the vertical curve is assumed equal to the length of the two tangents, right? Second assumption is that the curve is assumed to be equally long on either side of the apex point, right? If B is your apex point, then on either side of it, there has to be an equal length of the curves. That is T1 B1 is equivalent to B1 T2, and that is L. So again, the third assumption is that the length of the vertical curve, rather is our relationship that we have discussed earlier. The length of the vertical curve is given by the formula L is equal to G1 minus G2, or R being the rate of change of grade. And then the change of T1, this is the same thing, that will be equal to the change of B minus the length, this length, D T1, right? And the change of T2, that will be change of P plus, if you have change of P, you need to add up this tangent length over here, right? And then the reduced level of T1, that will be equals to reduced level of P plus minus length into G1 by 100. Similarly, reduced level of T2 or reduced level of P plus minus L into G2 over 100. And reduced level of B2, as you can see over in the figure as well, this is B2, so that will be an average of the reduced level of T1 and T2. So half of reduced level of T1 plus T2. And if you want to calculate the reduced level of this apex point B1, so that will be equals to the reduced level of half of reduced level of B plus reduced level of B2. And then the tangent correction at any distance x, yx, that will be equals to G1 minus G2 divided by 400 into L into x square. Okay, ji? And then you have to prepare the setting out table. Since the curve is symmetrical on both sides of the apex points, you only need to do the calculations for half side of the curve. For the other half side, the calculations, they will be the same. Now let us quickly go through one of the examples. Calculate the reduced level of various station packs on a vertical curve connecting two grades of plus 0.6% and negative 0.6%, right? So these are the two grades. The change and the reduced level of the intersection point are, that is point B, are 550, that is the change, and 325.50 meters respectively. Now this is the reduced level of that. The rate of change of grade is 0.1% per 30 meter.